Hopefully this is live. Let's see if some people connect and start typing. Hello? Okay, we're live. So, for those of you that don't know me, my name is Dan. I'll be doing a logic board repair stream. First board we are going to be working on is an A1708. So according to the customer, they took it to a U-break iFix. They told them that it's a PMIC related failure, so it's a logic board issue. From first glance, just looking at this board, let me put it under the microscope so you guys can see better. It looks like someone might have cleaned this. And I'll show you guys an easy way to tell. Switch to the microscope camera. You can kind of see like these, let me see if, yeah, you can see like these wet streaks all along the board. And it's, yeah, more prevalent here near these MOSFETs. Doesn't look like anyone worked on this like flux-wise or soldering-wise. It just looks like they might have cleaned it before. So we might be, you know, some might not be able to see some corrosion if there was corrosion. So first thing I'm gonna do is plug this in and see how much amperage we're taking, how much voltage on each port. Okay, as you can see, this port isn't doing anything. This one's stuck at 5 volts, 370 milliamps. Oh, this one actually turns on. You have 20 volts on that port. But this one doesn't turn on. Let's switch to this side. Yep, this one turns on. And this one does nothing. So as you guys know from a lot of the videos on Lewis's channel, when one port isn't working, it's usually a CD3215 issue, right? So we see one port's turning on, one port isn't. I'd guess if you were to plug this in and put it under the thermal camera, one of the CDs that are bad would get hot. But the first thing I'm going to do is let's pull up the schematic and board view, and we're going to measure which one's bad. For those of you that, you know, don't have access to a thermal cam or other methods. So first, let's check which port was the one that wasn't working. I'm just going to double check so that I know. Just quickly plug this in. Okay, so it's the port closer to the edge of the board. And if we look at the schematic, I'm going to choose this port, choose one of these power lines that are nearby. And it should be, okay, and you choose a different one, something that actually goes to the CD, but it's probably going to be the one on the right. Yep, there we go. It is the one on the right. And another way to tell is we're going to go to this CD, 3215. We're going to click, well, if you go to the schematic, the actual schematic itself, click here, just go to the next page until we get to that CD that is questionable and not working. So just zoom out. And there's these signals called LDOs coming out of the CD3215, and that's how we'll know if it's working or not. So let's go ahead and switch to the microscope, and we're just going to measure that LDO. So we're going to measure we're not going to measure the voltage, we're just going to measure if it's shorted to see if that CD3215 is bad. So as you guys can see from the schematic, we're just going to go here, find the LDOs, usually on these bigger caps around, as well as 3v3, G3 hot, and then we have 3v3 LDO. I think there's also, should be some other ones. Let's see, I think it's 1v8, yeah, 1v8 LDO. We're just going to measure 3v3 LDO. Just open up the multimeter software. Just grab our probes. And we're going to measure on that cap right above it. Just adjust this for my eyes because Paul was working on here. There we go. You guys can see that perfectly. So we're just going to go to that cap. We're going to measure it to ground. Oh, set to voltage. There we go. We have 7 ohms. So that CD3215 is shorted. Now if we switch back to the schematic and board view, let's measure the other one. But it's working, so it should be fine. But for anyone's sake, it's basically in the same spot. But it's working, so it won't be shorted. There we go. Yep. And neither of these caps are shorted. So let's go ahead and switch out the CD3215. First thing you want to do is take it off. So let's put a bunch of flux on here. I'm gonna turn on this fume extractor. So we don't want to breathe in those fumes. And I'm gonna take this multimeter software off the board for now, off the stream. Hope you guys can hear me properly too. And I'm just going to use max heat and max air. You do want to be careful, so one tip is, you do want to be careful when working in this area. I'm just going to show you guys on the overhead camera. Just generally working on this wing of the board, especially in this area. On the other side of this, on the 1708 model, you have this camera chip that's responsible for webcam. I think this is webcam memory, I'm not 100% sure. But it's underfilled on almost every single board. There's very few without underfill. But if you heat up too much in this specific area right here, let's say for example you're trying to take off these MOSFETs for the CD3215s and USB connection, a lot of the times you'll overheat the board and the solder balls will pop out from under the underfilled chip, and pretty much you have to take it off and reball it, which is a real pain due to how large the component is, and since there's underfill, it's just very annoying. So you have to be really careful when heating up this area. So what I typically like to do is I'll cover it with a shield in that area just so it can take a little bit more heat. But I also want to point the hot air this way, away from the camera chip, because it's somewhere around here, right on the other side of the board. So I'll point my hot air in the other direction, as to not overheat it too much. But you just want to be really careful with how much heat you're using in this area. That's why some people also like to use less heat in that area, but generally if you're pointing it in the other direction, you shouldn't have any issues. It's mostly when you're taking these MOSFETs off, if you ever have to replace those. Just going to gently hold on to this. You don't want to yank at the chip either when you're taking it off, because you don't want to rip any pads. You just want to gently wait until that chip starts to move. And you can move your tweezers a little bit out and you'll see it start to move like that. I'm just going to gently lift it off the board. Okay. Next thing you want to do is wick those pads. Oh, another thing you can do to check to see if the CD3215 itself was the issue is we're going to go ahead and measure. Let's go back to the schematic so I can show you. We're going to go ahead and measure this LDO one more time and see if it's shorted now that we took the component off. So go to this. First thing I'm going to do is, because I did link some of those pads when I was pulling it off, so I'm just going to gently run this iron on it to pull off some of the excess solder once it heats up. Just want to make sure none of these pads are linked together. And we move some of those resistors, so we just put those back. Yeah, you want to be careful when you're working around this area because all these components are really close. Here we go. And now let's go ahead and measure ohms to ground on that signal. Oh, you actually want to be careful because you can see a little bit of that solder from the iron touch these two caps, and they're really, really close together, so they can get really annoying to separate. So what I'm going to do is I'm just going to pull this off. And we're going to put this back on. Okay. Yep, now they're not bridged together. Like Brian said in the... Oh, slight buffering. Not sure why it's doing that, actually. Let's go ahead and measure this. And it's not shorted anymore. So that's how we know the CD3215 was the issue in that case. So what we're going to do now is I'm going to grab some goot wick. Personally, I like to use the 2mm. There's two different ways you can do this. Like I've said in the past streams I've done, my favorite way is to hold it with tweezers and just hot air. But you do want to be careful with how much hot air, like I said before, how much hot air you're using in this area. But I tend to do this pretty quick. But you can also just use the soldering iron and apply it to the wick. You also don't have to use as much airflow if you do my method. Use just enough to heat that solder and the wick itself. So let's lower this air outflow to about, I'm going to do 500 heat and about, 75 air, as before I was using 120, because there's no need to have that much airflow. We don't want to heat too much of this board, just in that specific area. So I like to hold it like this with my tweezers. And I'm going to open the door because Oreo is yelling. More flux. Well, that's a decent amount. We'll put more when we're putting it on. And now I'm going to heat it back up. And we're just going to gently glide this, and you'll see that solder will come off nicely. If you're having trouble, you can put a little bit more flux to it and make it easier. And I'm just going to go all around. Being very careful not to touch anything like I did before. And those pads will become nice, flat, and shiny. You want to get as much off as possible, because if you don't, your CD3215 might not sit properly, right? Okay, that should be good enough. Oh, there's one more pad right there. It's a little bit too much on it. There we go. So I'm going to grab a brand new CD3215 that we saw on our site. If you don't have access to well, you could grab from a donor board. Typically, I tend not to, because I don't know if those CD3215s are good. So I use the ones that we sell on our site. I rarely ever have trouble with those. You recommend hot tweezers or regular tip? I always use regular tip. I don't like the hot tweezers, but I'm not really used to using them. I always started with just regular tip. Okay, so I'm just going to go ahead and Q-tip with alcohol some of this old flux. And those pads look really clean. Now, we want to see which pad, if we switch back to the schematic and board view, we want to see the orientation of the chip, which is marked by this red dot. that says pin 1. And if we switch back to the CD that I grabbed, you can see that's one more time. Yep, top right. The CD3215 has a dot on it, which on this case is the top right. So we're going to put it down in that orientation. I see a Jacek in the chat, a fellow Polish person. And that should be enough flux. I tend not to put too much flux when I'm putting these CD3215s on because we don't want it to flow out of place. So I'll heat the flux that I put down just to spread it a little bit. And then I want to line this up as close as possible. So what I'm going to do is I'm going to move it up a little bit. And then I'm going to gently glide it into place down here without heating as I'm doing this. Then once I find the right spot, just want to make sure it's okay, there's nothing on there. And I want to line it up as close as possible. So I'll usually line up the sides first so you can see those balls are pretty even. And I'll just tap it down until about, I think the rows are accurate, right? Something like this. Then I want to start heating from further away, let that flux escape, so the air doesn't knock it around. And we're just going to heat it up and slowly move closer once that flux starts escaping from under the chip. Like I said, you don't want to heat up too much in this area, but once that chip starts to wiggle and you saw it flow into place, that should be good. So let's go ahead, use some rapid cooling technology to cool down this board. Just putting it in front of the fume extractor so the air will cool it down quicker. And we'll see if there's any changes to those ports. One of them was already working, but we'll see if the second one is working. Very common issue on these. It's like I always recommended. Anyone that's working on these, this one isn't a touch bar model. I kind of just call them. I call them touch bar models. But anything like 1708 and newer, so 1706 and everything newer up to date, have these CD3215s or CD3217s. Probably the most important thing to know on these boards. Like a large majority of them, that's usually the problem. Of course, there's other issues like liquid damage could cause something, but they fail very often. So let's go ahead, now that's nice and cooled down. This port was working before, it's going to double check that it's still working. 20 volts, yep, 500 milliamps, just about right for this board to turn on. And now let's try the other port. Nope, so it's already turning on, but let's see if it takes the proper voltage. 20 volts, yep. 500. Now I want to double check both ports on the other side to make sure anything else isn't wrong. Yeah, the right CD3215 was shorted. That was the issue someone was asking in chat. Okay, this side works. And this port is for the CD that we changed, that was shorted. Can be caused by a lot of things. A lot of people plug in non-genuine chargers, or, they say they were charging their phone on that port, or sometimes you see these crazy pictures of people having like a hub with 30 different things plugged into it. And they'll say, oh, it sparked and shut down. Okay, well, that's turning on. Now we're going to double check. I just want to show everyone quickly because some people are asking. One more time. We measured the LDO on this right CD3215. Both of these have an LDO. This one was shorted. That port originally wasn't working. The other one was working. So I'm going to go ahead and put this in the device and see if we get image. I also like to take the SSD out whenever I'm working on a board, because you don't want to lose the customer's data. All of the equipment that Lewis uses is in his YouTube description of any of these board repair videos, so I think he has a link to it as well in all of his descriptions. So we're just going to quickly reassemble this and see if we have image. Also going to have to clean that flux off, but I'll probably just UC a little bit of the wing. We don't really need one, Sam. We rarely use them. Okay, there we go. Just gonna grab a battery screw for this. Realistically, you don't have to plug anything in, just the screen, trackpad, maybe the battery, keyboard. Are there any broken M2s? I have not seen any M2s yet. We've seen a lot of M1. Oh, seen a lot of M1s, and I think the newer M1s as well, but no M2s. But I wouldn't doubt if we'll see one soon, if they're already released. I haven't really been keeping up to date on those. I want to make sure you plug in the battery last too, so we don't kill anything. Make sure I'm not showing anything. And I'm just going to cover this up so I don't accidentally dox someone. I want to see if we have image. Yep, there we go, we have image. I'm just gonna, yeah, okay, good thing I didn't show that. So, we have image. I'm just gonna close this so I don't accidentally dox the customer. But it's booting to login. I don't have the password, but we could also boot externally to test on this. But everything should work if it was just that CD3215. So I'm going to put this to the side, and I actually have another board we can work on. So this one is fixed. Personally, this is probably one of the most common issues on these, so it's really good to know those. CD3215s, how to replace them, how to diagnose them. You'll see it a lot. So it's like one of the basics, I would say, for these newer models to learn. So let's grab, let's switch to camera. I'm going to grab another device. It's a 1932. Which is a MacBook Air. So it was, oh, and it wasn't the PMIC on that one, like uBreakIFix said, but I'm glad that they were trying to at least diagnose it, right? Said they couldn't fix the board, but they tried to diagnose it. Just put this housing to the side. Okay. Next board, 1932, the MacBook Air, newer ones. I'm not sure exactly what year this is, maybe like 2018. Don't quote me on that one, so I'm not sure. But many people will tell you they hate working on these. They have a lot of random failures, like rabbit hole type failures. What's the percentage of Apple's manufacturing fault versus spills and falls? It's honestly hard to tell. A lot of the stuff, so our store, a lot of the stuff we get is liquid damage. Just, I don't know, I guess many other people don't like to work, other shops don't like to work on liquid damage, so we get a ton of liquid damage stuff. But there's also stuff like that. CD3215 failing could have been caused by anything. Could have just been a design fault, anything like that. Customers should have backups. Yeah, most customers don't. So, first thing I'm going to do here, just check how much it's taking. 5 volts. Okay, so we're getting 20 volts. But it looks like our amperage is fluctuating. Yeah, see, it goes to 50 milliamps, then to 0, then 50. Which is never a good sign. Let's double check the other port's doing the same thing. But since we have 20 volts, I don't think this one will be a CD3215 issue. Okay, 20 volts again, and both ports are doing the same thing. Usually for me, the first thing that will pop into my head is what's wrong with this board is two things. Something's shorted, or there's liquid damage somewhere. So the first power line I'm going to measure is PP bus G3 hot. That's the first thing I like to do on these boards. If I can't direct so. PP bus can be found on this cap right here. I'll show you guys on the schematic as well. Let me just open it up. Let's go 01521. Just turn this board around. Okay, switch to schematic and board view. We're going to measure PP bus G3 hot, which is the main power rail on most of these boards. Right here, as you can see, there's a ton of places you can measure this on. Just easy here because it's a big cap, very easy to measure on. So, let's go ahead and find that cap. Just gonna plug in my amp meter. And like we said, it's taking 20 volts and about 50 milliamps, but it was fluctuating between 0 and 50. So let's find that cap and measure a PP bus so we can get a better idea of what's going on. Let me restart this amp meter, it's acting up a little bit. There we go. So, not sure why it's not updating on this stream. Okay, I'm not sure why this stream is acting up with the multimeter software, but it's 12.3 volts. Let me see if I have to restart this program very quickly so you guys can follow along. Okay, the program stopped responding. Let me see if I can reopen this for you guys. Yeah, it's a very small board. That's why most people don't like working on these as well. Usually when there's liquid damage, it gets pretty bad as well. Just because of how small it is and everything's so close together. Okay, so the multimeter software for some reason isn't working. So I guess you guys are just going to have to bear with me so I can tell you what the measurement is. And it was 12.3 volts. Which is wrong because it should be 12.6 or higher. It's like up to 13 on these boards. But I think 12.6 is what it should be. So what I'm going to do now, let me go ahead and look over this board and see if I can find anything corroded. Which I like to do just from a visual inspection. My eyes spot this stuff pretty quickly. But there's a lot of the times where I'll grab a board and I'll just go straight to the microscope, if we can do together, and see if we can find something corroded. So I'm just going to run along this board, starting from this edge, and see if we can find any corrosion. Could even be like a minuscule amount of corrosion, like even one cap or one resistor in this case. Another area that tends to get corroded is right down here, near the edge of the board. Move this out of the way so you guys can see. Right down here along this edge of the board gets, most of the times it gets corroded. And we have our PMIC, which looks okay. We've been noticing a lot of those failing recently. There's some hair on there. Let's get that out of there. No, this is a MacBook Air, but one of the newer MacBook Airs, not the old A1466. And just keep going along, see if we can find something corroded. Or something that looks burnt as well. Maybe you'll notice a component with a hole in it, like Paul did earlier. I think he had an SMC failure. All I see is really like food crumbs. This is the CD3215s, which are also on this board, like that 1708. Oh. And there we go. Looks like we might have found our failure. So what this chip is, it's a TPS. Switch to the schematic and board view. See exactly what this is responsible for. Right here, this guy used 7650. Let me just click off that so you guys can actually see. TPS. Looks like it produces 5 volt, the 5 volt G3S power line. 5V G3S. So what I'm going to do is I'm going to go ahead and measure that 5V G3S and see what we're getting. I know where most of these power lines are. I know it's right here. Just on these big caps right here on the bottom left, right under the T2. Just want to see quickly if that multimeter software is working. Oh. Still doesn't seem to be working, so I guess we're gonna have to. Can't use that. So I'm gonna plug this in again and see what our board is doing now. Okay, so like I said, we're gonna measure on these big caps that we saw on the schematic. So you guys can't see what it's doing. I apologize about that. Just multimeter software is bugging out. But it's fluctuating. It's going for like 0.8 volts down to, from 0 to 1 volt, and it's jumping up and down. Signifying that there's an issue on that line. And since we saw it was corroded, I'm just going to go ahead and switch that out and see what happens. If you also want to switch to the schematic and board view, we can see exactly which power line corroded there. As you can see, this 5VG3S, which we were checking on this capacitor, is in the exact spot that's corroded. See, 5VG3S and a bunch of other signals that are produced by TPS. So let's go ahead and replace it. Nice big old glob of flux for you guys. There's nothing to really worry about in this area, so you don't really have to worry about heat. Nothing underfilled around it or anything like that. Well, you never want to overheat the board either way. Looks like this resistor might be a little bit corroded as well. There's a Paul amount of flux, there's a Lewis amount of flux, and then there's the right amount of flux. How much I use. Okay. Yeah, as you guys can see, there's a nice little glob of corrosion right there. I'm going to take some of these, I'm going to take this resistor off. I'm going to replace that as well because I don't like how it looks. The good thing is these pads are all still there. Oh, except for that one. Yeah. You can see that pad looks like it's missing. You can kind of see right here, it's covered in corrosion. The good thing is that the pad is still there. Just got to scrape at it and put some new solder and it should be fine. So I'm just going to lightly scrape at this. Might need some conformal coating because the conformal coating that comes from the board is kind of falling apart here as well from the corrosion. We want to make sure that this trace is also functioning properly. The first thing I'm going to do is just clean it up with some alcohol. And it actually doesn't look too bad. What I like to do is I'll grab the micro pencil and I'll just lightly scrape away. I just need a new blade for this micro pencil. Lightly scrape away until it gets that nice coppery color. We'll do that right here too. Then once it has that nice copper color, you can go ahead and put new solder on it. Yeah, so this actually doesn't look too bad. Doesn't look like we're gonna have to remake any pads. Grab the soldering iron and we're going to put some new solder on there. Don't have to put too much. You don't want that coming out from under the chip, but enough so that the chip can have a proper connection. There, we want to put a... Just going to turn it around so it's easier to manipulate. You can also just touch the end of it. Attached to there. There we go. That should be enough. Okay, so I'm going to grab a donor board. I'm just going to quickly swap what was missing or was corroded. Let's put a bunch of flux. Let's put a little bit more on there for you Lewis flux enjoyers. Someone says they're new and it looks very complicated. It becomes easier once you do it a lot, but something like this I'd say is like your average liquid damage repair. Not too bad. It definitely gets much worse, but it also gets easier. It could have been just like that one capacitor. You just want to be really gentle when you're working with areas like that where all the pads are corroded and whatnot. Bear with me quickly. I'm just taking this TPS off of a donor board. Actually, I'm going to do the smaller components first. So I'm going to do this capacitor and stuff, then it'll be easier to place. I have OCD, so I want to make sure this looks like new, lined up properly. Can that one chip being corroded cause other components to be damaged or other parts? Yeah, it depends what's corroded, right? So you could have a really common thing that happens is on 1708 boards where the area near the Wi-Fi chip gets corroded and then PP bus gets sent to the CPU, right? So we don't know what these power lines are around it, but let's say, you know, the corrosion bridges two different components together and one power line sends another power line to something that's much less voltage, and it can kill your board. But that's, you know, it's not caused by us, it's just caused by the general corrosion. So it depends, yeah, of course corrosion can kill something else. We won't know until we replace it in this situation. What I'm going to do quickly, So I want to check if that pad that was scraped at. Just going to check if it has connection. Yeah, so it's 0 ohms, that means that connection is fine. It wasn't corroded away. Thank you everyone for watching. If you do enjoy, then leave a like so we'll do some more board repair streams. Just gonna multitask. We're gonna put some flux while I'm heating up the other board. So, in this case, it doesn't really matter how much flux is under the chip. Since there's no balls, we can just push this chip into place. And you'll see it nicely flow into place once that solder melts. And you see that solder on the sides get all shiny, and that chip nicely kind of flows into where it's supposed to be. And if we tap it lightly, or press it down, there we go. It'll connect with the board. Thing is, Lewis doesn't have a smaller... I want to touch this solder ball up, but I also don't want to move the components next to it, and Lewis only has a big tip, so we're going to try to do this very gently. But I'll probably fix this up a little bit at my own desk, just because I want it to look nice. There we go. We didn't move anything either. I also don't like how that pad looks, but I'll touch it up a little bit with my smaller iron at my desk. Need to order Lewis a new one, actually. So let's go ahead and cool this board off. This was a donor board I was grabbing from. I'm just gonna cool it down a little bit. It's not that they move less when there's solder on both sides. It's just, in this case, when you're putting on a chip like the CD3215 and it has solder balls on the chip, if you have flux under it, that flux might get between the chip and the pads for the board, for example. So like right here, what's missing. And if there's flux, it might move out of the way when you're blowing hot air at it. If you have your air too high. In this case, you can kind of press it down because it doesn't matter if the solder comes out from under. How long does it take to do a repair like this? I would say something like this to find, diagnose, and fix, maybe about 20 minutes. For this case, because this is something that's, in general for us, a little bit easier. But we also don't know if it's fixed yet. But there's some times where, for example, on this board, you'll have, this whole wing is corroded, so you have a ton of work to fix. It's a very small board, yeah, it's from the A1932 MacBook Air. So before we had 20 volts, 50 milliamps. Let's see what happens now. Okay, we have 20 volts, 30, 50, 70, 80. Hopefully it goes a little, oh, there we go, 400. That should be turning. That's enough for the MacBook Air to turn on. It takes substantially less amperage to turn on. And I just want to double check the other port. That's just really common for us to do here when we work on these. Make sure all the ports work, due to how often those CD3215s fail. Okay, that looks good. I'm going to go ahead and throw it in the housing, just to see if we have image. And again, you don't have to connect everything for just quick testing like this, but I'm not going to connect everything because I know I'm going to be taking this board out to clean it still, and I want to touch up that TPS. Make sure all those joints look nice. So I'm going to connect the charge port. Just want to be really... There we go. I'm going to connect the screen. Trackpad. And I'll usually leave everything else unplugged. You can connect the battery if you'd like. How long have I been doing this stuff for? So I've been working here for 3 years now. As of this summer, it will be 3 years. The first year, a little bit about a year, maybe a little bit more, I did shipping. And then Lewis gave me the opportunity to do board repair. So I've been doing this for probably a little bit under 2 years. Okay, so plug this in. I'm going to cover this up so we can only see the Apple logo because I don't want to dox our customer. Okay, so it's taking 20 volts. It's at 300 milliamps. Oh, there we go. We have Apple logo. I just don't want to dox this customer, so that should be good enough for our testing. And it should have no problem booting to login. Okay, so just to do a quick overview of this board, let me just switch to the schematic board view. So the first thing we saw was that when we plugged it in, it was taking 20 volts and 50 milliamps, jumping between 0 amps and 50 milliamps, somewhere about there. So we went around, we checked PP bus, which was 12.3, so we saw an issue there. We checked 5VG3S. Well, we found corrosion on TPS. We checked what was corroded, 5VG3S. When we checked that power line, it was going to about 1 volt and then dropping to 0, when it should be 5 volts. So we went ahead and replaced this guy. This capacitor was this resistor was corroded. This capacitor was missing a pad. So we went ahead and fixed that up, and it's working. So this should all work properly. I'm just going to go ahead and do full testing and clean up this board. So we want to make sure we clean that flux off. I think Paul mentioned earlier we use no clean flux, so technically you don't have to, but it just looks unprofessional if you leave flux on the board. So we just want to make sure it looks like it's basically the way you got it from Apple. Okay, so thank you everyone for watching. Hopefully you guys learned something, and hopefully I'll see you again soon. Thank you for watching.